Hey, this is Will from SRT Amplification, and today on the bench we have another piece of Heathkit gear. Today it's a audio generator, model IG-1272, and I haven't even powered this thing up yet. I don't even know if it works. If you'll remember, I've done several pieces of Heathkit gear in other videos. I did this CT1 capacitor tester. I also did a VTVM here a while back, and fortunately both of those actually worked. I had to kind of rebuild some of the VTVM to get it to work, but it calibrated all right, and this capacitor checker was in the last video, and it actually worked just fine as well, and I'm hoping that this one does as well. So before I plug it in, I'm going to take this cover off, and we're going to look on the inside of it and make sure that there's no gross faults or anything that I can see, and then we'll power this thing up on the Variac and see if it actually produces a signal. With this particular model, it's just an audio generator. It goes up to, let's see, 90,000 hertz, which is past the audio spectrum, but it's not into the RF spectrum yet. So this is perfect for what I do with audio. I have this digital frequency generator, arbitrary wave generator, whatever you want to call it. But, it's all menu driven, and you have to punch it in. And if you want to do a sweep, you got to program the sweep, or you can step it up or down incrementally in increments. But this one, not only can you, dial in whatever frequency you want with these buttons, but then you can also press the 0 button on each one of these lines, and you've got a manual kind of a sweep here, which I really like, because when you're doing frequency response stuff on an amplifier or whatever, this really helps to kind of dial in where that 3 dB down is, or whatever, where you're making your Bodie plot or whatever. But yeah, so let's take this cover off real quick on the top here and see what this thing looks like on the inside, and then we'll power it up. Another thing about this, even if you are doing RF work with radios or what have you, you could use this to modulate an audio signal onto that RF signal. I know a lot of your function signal generators or whatever, has that capability of doing both the audio and the RF. But if you wanted, a separate audio, because you are going to get to a point in the radio circuits where you're going to need, audio as well. So you could inject the audio right into the stage after the RF and the IF stages. So this could come in handy. Well, let's look at it. Let me get this thing apart. These are flat head screws here, which is kind of odd. You don't typically see flathead screws holding covers and stuff on. The vintage on this, I'm going to say probably right around the same time as that VTVM I did. I know it's in the same line as the VTVM, so this blue cover was basically around the same time frame. I'm gonna say late 60s time frame. I'm thinking maybe early 70s. I got this off of eBay. Like I said, I do not know if it works or not. I'm going to be powering it up right here for the very first time. So, I just really don't like flathead screws. That's just crazy. There's 6 screws up here on this top panel that we got to get out, and then once these are out, it should be able to see pretty much everything. And what I'm really particularly wanting to look at is the power supply area, to make sure that I am going to power this up on the Variac, but I just want to make sure that we're actually you know, not shorted something out in here or whatever. Okay, so there's the cover. And let's get a closer look back here on the power supply. Looks like we're fused. I'm gonna go ahead and check that fuse. Fuse real quick. Looks like it's intact. It is a, if I can get this on the camera or not. .5 amp fuse. See it right there, 1/2 amp. Okay, let's check the continuity on that. It is good. Okay, so fuse is good. We'll stick that back in there. Looks like we got the hot wire. This is a polarized plug with the grounding. So this may be a little later than I'm thinking. It's probably, I'm going to say now with this plug, it's a 3-prong plug. It could still be late 60s, but I'm thinking maybe now early 70s probably. Late 60s, early 70s, somewhere in that time period. So it looks like we got the hot. I haven't looked at the schematics on this, so I'll have to pull them up, but the hot's fused. It goes down and comes out down here, comes around here, and then goes to the power switch. Okay, on the front. Out of the power switch, back here to this switch back here. Let's see what that switch is on the back. Turn this thing around. I guess it's a 120. It's a dual. Yeah, it's a dual voltage switch right here, and we got it set for 120. So that's what that's doing. It's just putting the windings of the transformer into play for whatever line voltage we're working on. So that's good. And that is feeding the actual transformer. And then out of the transformer, we're coming back to the neutral side of this line over here. And then we got the ground connected. Okay, so we do have a cap across this line. It looks to be some kind of RFI filter network here. So that's not a death cap. It's not going, it's not going from the line to ground there. So nothing to worry about there. This is just some kind of interference network right here, some kind of filter network. Okay, so it looks good. It doesn't look like we have any problems here. I can do a continuity test on this transformer real quick to see if we got a short or anything in the power transformer. So let's stick this in here. So I'm going to go right across the windings of the transformer here. Let's see. Boom, boom. Let's see what I'm doing. And the power switch is in there, so let me turn the power switch on. Okay. So now we should get a reading here. And that's 120 ohms across the primary winding. So, okay, here we go. It looks good. The secondary is coming out on the red and the green, and that's right here, and that's 13 ohms. Okay, so that looks good right there. So it doesn't look like we have any shorts, and we have continuity throughout through the power switch and everything, and through the 12220 switch over here. So that's all good. Let's power this thing up on the Variac and see what it does. Okay, so I got this thing powered up, got the Variac on, bringing it up slowly. All right, so we're at about 66 volts here. Let me get this in the frame where you can see it. We're at about 66 volts, and we're not drawing any current. 10 milliamps of current maybe. Let's see. Yeah, that's just residual current there. Not drawing anything. Bringing it up to 85, 87. Oh, we got 20 milliamps. Remember, this is a half amp fuse we have on here, so we don't expect to see a lot of current really. And we'll get this thing up to 120, fully powered on. Okay, so we'll leave it right there. It's 119 volts. We're drawing 20 milliamps, 0.8 watts. All right, so far so good. We do have a pilot light that has come on, so we know our power supply is working. So what I'm going to do now is I'm going to get my BNC cable, connector cable here, and we will hook this thing up to the O-scope and look at it, see what it looks like. All right, so here's our 10 volts out. This is up to 10 volts. Okay, so right here is our variable frequency that we can actually do a sweep on, and this is our level. So we don't have any okay, so this, yeah, let me get these off of here. These buttons are going to have to be cleaned. I know that they're kind of sticking. Okay, so we're going to go with 1, okay, and a multiplier of 1,000, so that'd be 1 kHz. Let's see what we got on our O-scope over here. Okay, so looking at this on the O-scope, I got the signal on here. It is working. I've got this set for 5 volts per division. So we're looking at 10 volts peak on this, which is, I guess, what this thing's supposed to put out. So it is really touchy on the voltage. And then there's some places in here where it cuts out. And then as you turn it, it just goes away. So I don't know quite what's wrong with that. There's some spots in there that are so that is that's back to 5. Let's see. There's 2 volts per division. So that would be about 8 volts peak. Or about 4 volts peak. Yeah. So yeah, it's working. Let's see if I can sweep the frequency here manually and see what happens here. So I'll push the 0 button, and now it's wherever the frequency is not changing. Maybe I have to take the multiplier off. I'm not sure about that. Take the multiplier off maybe. Nope. Okay, here we go. A little bit. No, that's adjusting the amplitude for some reason. So the sweep part is not working.
Sorry, I don't understand.
The sweep portion is not working, and it seems to be stuck on a particular frequency no matter what you press. Well, I went to the 1000. Oh, there it went. Yeah, it seems to stay on the same frequency no matter what. No matter what I do, the frequency doesn't change at all, as you can see. Now when I hit the attenuator, so now we don't have anything out. Okay, here we go. Hit the attenuator, goes away. Let's see here. Interesting. Okay. Oh, see, there's intermittent. There's some of the issue right there. I think I've got an intermittent connector problem right here. When I vibrate this, well, now it's not doing it. Okay, so hey, it works. So I think in part 2 of this video, what I'm gonna do is actually clean all of these switches. Clean them all real good. I noticed that the voltmeter is not working because obviously, like right here, I'm changing the voltage on this wave, and I get nothing on this voltmeter. So we'll clean up these sticky switches. We will see, that one's not going in at all, so that one's messed up really bad. The 1x multiplier is messed up. So I think in the next video what we'll look at is cleaning all this stuff and see what it does for us. We kind of have a baseline on the way it's operating right now, and clean these pots, the amplitude and the frequency sweep pot, and check out this voltmeter and see what's wrong with that. But I'm just happy that it's actually working. So stay tuned for the next iteration on this, and we will have an update on what this thing is doing. Until then, thank you for watching.